In this video, I will explain you applications of polarization. These are very simple. All these points are focusing on a certain area where we are reducing the intensity of light. So first thing we will see, to cut the glare. Now from a car headlight, light rays are coming out, but the coming light rays are having oscillations in all the directions. So as it carries all the oscillations, it would be an intense beam which is received at our eyes. Okay, now see, if the beam is having intensity, we have no use with that. Let's say with lesser intensity also we can see an object. For example, we just visualize, just imagine that you are seeing a tree on a sunny day at 12 o'clock in the noon, and also at 4 o'clock in the evening. Now at 12 o'clock in the noon, it would be very high intense light, right? That actually create a good picture, but it is creating certain irritation with our human eye. But at the same time, at 4 o'clock or at 6 o'clock in the evening, the light intensity is less. That is also giving it as a good clarity picture, but there we are comfortable to see the object, right? So at one place, here in this case, it is having light in all the oscillations, in all the directions, these are oscillating. Now when we are keeping a polarizer here, now the light intensity is, light is restricted to oscillate only in one direction. So what will happen? Instead of human eye receiving this intense beam that creates an irritation to our eye, now we only have to see this thing. Intensity is reduced. So we are comfortable with this. So to cut glare, so that is used in our car. The front screen. Okay, to cut the glare. So opposite car coming. Okay, so if this is a polarized screen, then we will have less intense light, but that will also give a clear picture. Okay, now we will see the next application, that is in 3D movies. In 3D movies, we are provided with a glass to see the movies, right? Now one glass will have a polarizer in this way, and another glass will have a polarizer in this way, which means only light with these oscillations is allowed to fall. This is extraordinary light, extraordinary ray, and this is ordinary ray, ordinary ray. So this glass doesn't allow extraordinary ray to pass, and this will not allow ordinary ray to pass. This will only allow extraordinary ray to pass, and this is only allow ordinary ray to pass. Now in 3D movie cinematography, we will take the shots in two different angles, one with extraordinary ray and other with ordinary ray. Okay, now how we are able to see this thing in a 3D image? Because our left eye is taking one picture, this is this portion, and our right eye is taking this picture. Now this picture and this picture is processed on our retina, and that is giving us a 3D image. So we need two images to be processed at the same time to get a 3D image. But when I am seeing a picture that is a 2D picture, that is only one image. So we need two dimensions. So one this angle and another this angle. So these two are captured and processed at our eye, our brain, to get a 3D picture. So similarly, we will shoot one angle with extraordinary ray, another angle with ordinary ray. Now in the 3D screen, from the screen we are getting ordinary ray and extraordinary ray, but ordinary ray can only pass through this, and extraordinary ray can pass through this, and ordinary ray carries one angle and extraordinary ray carries another angle. Okay, so this eye take only one, like we see in real life, this eye is taking one picture and this eye is taking another picture, and this picture, see the left eye, whatever the picture it is taking, that is not, you know, that cannot be taken with right eye. So these are two distinct pictures, but there are overlapping, but still I would say that these two are different angle. So these two images from the 3D picture is captured through two different glass, and on reaching retina, that will create a 3D picture. Okay. So this application in detail, this won't be asked in your examination. You can just say 3D movies. Next thing is filter in photography. That doesn't need any explanation. Polarized sunglass. So see, that can be used in normal classes also. So I can simply convert my normal glasses to polarized glasses. So if it is polarized glasses, then when I have an irritating intensity of light, this polarized glasses would be able to reduce the intensity by simply polarizing the light which is coming inward. Okay, this on converting into this, see, instead of 1, 2, 3 rays receiving, I just need to receive only one ray. So intensity would be less, still I would be able to see this. So this can be done with sunglasses also. Next thing is LCD screen. Now windows of aeroplane, same thing. Unpolarized light of higher intensity can be reduced into polarized light of lower intensity using a polarizer. Okay, so these are the applications. Just learn 5 or 6 applications. This can be asked for a 2-mark question. Okay, thank you.